There are many wonderful things that have come out of the era of cloud computing. But there's also some new complications. As we start moving to cloud computing, we get the ability to create microservices. We get the ability to rapidly deploy and see validation that what we deployed is working. And we get the ability as an organization to learn from our deployments, from our interactions with production, to become faster, more agile learning organization. So I like cloud computing. It's enabled a wonderful time in our industry, a wonderful era in our industry. But as I say, it also has some implied complexity, some implied costs. What happens when we start moving to microservices and everything now starts to be a matter of network communication? What kind of complexity is introduced as a result of that distribution, of that move to network services? How often and how easily do we run the risk of running afoul of the fallacies of distributed computing? These are the things that we need to care about, and the things that we had to care about even before become more important. They become more critical, that we think about them and we care about them now. It's not like we didn't have to think about threads before. It's just that even if you didn't think about it, the scale would be so low that you may not even notice it was a problem. And we even had that wonderful sort of blissed interstitial period between, let's say, 2007 until, I don't know, recently, where you could just kind of fake it. You know, if you couldn't handle the number of requests that you were getting, just spin up more nodes, right? You had cloud computing, you could do horizontal scale. As long as you're doing microservices, that was an option. But now we're starting to see that scale is it can become so overwhelming that our ability to handle that load efficiently and cost effectively is diminished if we keep relying on these old crutches. So reactive programming gives us a way to be more efficient and more robust in the individual services. It allows us to cost effectively move data across the wire. It allows us to build services that are more reliable, more resilient. So if something should start to overwhelm a producer or consumer, we have a way to deal with that excess demand. Reactive programming gives us a way to build more stable services in the face of increasing volatility and distribution. So I like reactive programming. I really think it's got a lot of potential, and its foundations are in large organizations that want to build applications at scale that do the right thing in the face of these kinds of externalities. So in this video, my friends, we're going to take a look at the basics of reactive programming. We're going to look at the foundational layers, things like Reactor and the Spring integrations for reactive programming. We're going to look at reactive data access, and there's a lot here because every day and every way we get new opportunities for building reactive NoSQL and SQL solutions. Then we're going to look at building reactive HTTP services, regular sort of Spring WebFlux-based REST APIs and the like. We're going to then look at Spring's reactive WebSocket support. We'll look at how to talk to HTTP services using the Spring Web Client, the non-blocking asynchronous I/O reactive HTTP client that ships with Spring WebFlux. And by the by, that one's one of those things where even if you're not using reactive APIs on the server, there's no reason you shouldn't be using the reactive web client on the client. It is too good not to use. Then we're going to look at RSocket. RSocket is a protocol that was designed by engineers at Netflix who then went to Facebook, where they developed it in such a way as to be useful for their particularly insane levels of scale. RSocket is a protocol that reifies the concepts of reactive programming on the wire. It makes it real so that you can build services that have back pressure in them as part of the protocol itself, not just an afterthought. Then we're going to look at GraphQL. Now, GraphQL is yet another protocol that was sort of developed at Facebook. GraphQL is a great way to build data integration gateways, and it's got a lot of potential to change the way that we build edge services and the way we think about exposing our endpoints for our clients, to reconcile the tension between individual, isolated, insulated microservices and the need for clients to have all the data co-located as efficiently as possible in one payload. And then we'll turn to Spring Security and how we can use reactive Spring Security to secure our services and our endpoints. We'll then look at Spring Cloud Gateway, which builds upon the reactive foundations of the core Spring framework to provide a microproxy and an API gateway all wrapped in one. We'll look at certain patterns that are supported there out of the box. And then as we kind of wind down, we'll look at different opportunities for integration with other Reactive Streams capable APIs in our look at the Reactive Streams themselves. And then finally, we'll look at testing. Things look very different when things are asynchronous and reactive, and testing has to change with that. And so in that chapter, we'll take a good deep look at some of the opportunities in some of the common areas where testing is concerned. I think it's going to be a lot of fun, and hopefully by the end of it, you'll learn that reactive programming is actually paradoxically a lot simpler than whatever it is we did before, because you can unlearn so many of the disparate APIs that we had for dealing with different kinds of data, different kinds of endpoints and cadences and so on, and just think about one thing: Reactive Streams. I am your host and author today, Josh Long, and I work on the Spring team, and we care about helping people get to production as quickly and safely as possible, and that's why we care about reactive programming. Hopefully, by the end of this video, you will too.